angles formed by intersecting lines related? Think about this question during the lesson. A skewed intersection has two roads that intersect at more than 20 degrees away from 90 degrees. Determine whether the road intersection shown is skewed by finding the measures of angle A, B, C, and angle D, B, E. Estimate the angle measures a skewed intersection might have. A skewed intersection would have angle measures less than 70 degrees or greater than 110 degrees. Let's examine how the angles are related. Angles opposite each other are called vertical angles. Vertical angles have equal measures. In this example, angle ABC and angle DBE are vertical angles. Angles that share a ray are called adjacent angles. Angle ABE and angle EBD are adjacent angles because they share ray BE. Now we're ready to write and solve an equation for the value of x. What justifies the equation the measure of angle ABC equals the measure of angle DBE?
Select your answer.
Angle ABC and angle DBE are vertical angles, so their measures are equal. Write the equation x plus 35 equals 2 times x minus 10. Solve the equation by adding 10 to both sides and simplifying. Then subtract x from both sides, so x equals 45. Now that we have identified the value of x, we still need to find the measure of an angle in the intersection. We can substitute the value of x into either expression in the diagram. Let's use the measure of angle ABC. Substitute 45 for x and simplify. The measure of the angle is 88 degrees. Angle ABC and angle DBE both measure 80 degrees. Since 80 degrees is within 20 degrees of 90 degrees, the road intersection is not skewed. Angle MNQ and angle PNR are vertical angles. What is the value of x?
So we're going to do exactly what the example showed us, and we know that the vertical angles are equal to each other, so we're going to write these equations as equal to each other, and then we're going to solve for x. So now we're going to add 6 to both sides here. It cancels, then we're left with 3x is equal to 120. And then we need to divide by 3 on both sides. I'm going to write it over here. 3x equals 120. I'm going to divide by 3 on both sides. That cancels out. I'm left with x. And then 120 divided by 3 is 40. So x is equal to 40. So in here would be the word equal. So the equation, fit it in here. 3x minus 6 equal to 114. It's supposed to be equal to 114 can be used to find x. The value of x is 40. And that's it.
Part A. Ray EG splits right angle DEF into two angles, angle DEG and angle GEF. Find the value of x.
All right, so we have complementary angles where it creates the right angle, and the sum of the two angles that is split by a ray will be equal to 90 when you add them together. For B,
Part B. The two angles shown are supplementary.
hold on, skipped a part. All right, so I already explained that. So angle DEG and angle GEF, when you add them together, should equal to 90. So 3x plus 36 is equal to 90. Then you subtract 36 from both sides, and you get 3x equals 54. And then you divide by 3, and you get x is equal to 18. So the answer for x is 18, and then you can find your sum of the actual angle degrees. And then we have the supplementary angles. They have a sum of 180. So when you add them up, they equal 180. So this one added to 50 equals 180. And then you have they subtracted 4 from the 50 to get 46. And then you add, subtract 46 on both sides. And you get 134 here, x over 2. And then you multiply by 2 on both sides. And then you get x is equal to 268.
Find the measure of angle PAR. How does the relationship between the measure of angle UAG and the measure of angle KAR help you to find the measure of angle PAR? The first step is to use vertical angles to find the value of x. The measure of angle UAG is equal to the measure of angle KAR. Substitute the expressions of x that represent the two angles. Then simplify the equation by subtracting 2x from both sides to find that 4x equals 16. Divide both sides by 4 to find that x equals 4. How can we use the solution x equals 4 to find the measure of angle KAR? Substitute 4 for x into the expressions for the angles. 6 times 4 equals 24, and 2 times 4 plus 16 also equals 24. The measure of both angle UAG and angle KAR equals 24 degrees. The next step is to identify complementary angles and use them to find the measure of angle PAR. Angle KAR is complementary to angle PAR, so the sum of their measures is equal to 90 degrees. Substitute 24 degrees for the measure of angle KAR and solve the equation to find that the measure of angle PAR is 66 degrees. The degree measure of angle 1 is 4 times the degree measure of angle 2. Angle 1 and angle 2 are complementary. Angle 1 and angle 3 are vertical angles. Angle 3 and angle 4 are supplementary. What are the measures of the 4 angles?
All right, so let's look at it this way. We have complementary angles. Complementary mean they are equal to 90 degrees. So angle 1 is 4 times angle 2. So angle 1 and angle 2 are 90 and they're complementary. So that's all of this. And supplementary are angles 1 and 3 are vertical, so not supplementary, vertical angles. And choose a different color. And the angle 3 and 4 are supplementary. All right, so let's start with the complementary angles. So Angle 1, okay, angle 1 and 2 are complementary. Now I have to try to draw this out so I can see what this might look like. Okay, so if angles 1 and 2 are complementary, that means this will be one, this will be one angle, that's another angle. Then angles, let's name this one angle 1. Let me write it over here. Angle 1, angle 2. And then we have 1 and 3 are vertical. So that means I have, this is my angle 3 because vertical are directly across. Okay, that's 1 and 3, not 2 and 3. My mistake. So 1 and 3 are vertical angles. So this is 3. And then we have 3 and 4 are supplementary. So supplementary angle would be equal to 180. So let's do angle 4 about here. All right, so let's go back to starting with the complementary angles for 1 and 2. So first it says angle 1 is 4 times angle 2. So angle 1 is 4 times angle 2 is equal to 4 times angle 2. Okay, so we need to solve for angle 1. And okay, let me rewrite this. Okay. All right, back to, all right, so I'm going to use just M instead of the angle part. So we know that 4 times M will give us the length or degrees of the angle 1. And then if we add the angle degree of angle 2, it should be equal to 90 since it's complementary angles. So then I'm going to solve for M. So 4M plus M, they are like terms. So that'll be 5M equals 90. And then we're going to divide by 5 to solve for M. And then we get M is equal to 18. So angle 1 is 18. I'm sorry, no, that's angle 2. Angle 2 is 18. And then 4 times 18 will give us angle 1. So that's going to be 72. So now we have for the complementary angles, now we must solve for the rest. So now, erase this. Now we're going to solve for the vertical angles. So the vertical angles are angle 1 and 3. So we know angle 1 is 72. We don't know angle 3. I'm going to make it an M again. And so the vertical angles, 72, not plus, but they're going to be equal to each other because vertical angles are supposed to be equal. So if angle 1 is 72, angle 3 must also equal 72. So now we need to look at angles 3 and 4, which are supplementary, and supplementary angles equal 180. We have 72 plus angle 4, let's make that an M, is equal to 180. 80. Let's solve for m. So we're going to subtract 72 from both sides. That cancels. We got m. And then 180 minus 72 is 108. So angle 4 is 108. So it says, what are the 4 measures? And our 4 measures are 72, 18, 72, and 100, 108.